Assalamu alaikum wa rahmatullahi wa barakatuh.
So today we're going to be working on the question on the screen. First, we're given an equation where ethanol reacts with oxygen to give us carbon dioxide and water. This particular reaction is called a combustion reaction. And we're given the change in internal, sorry, yeah. So we're given the change in internal energy of the reaction to be negative 1373 kilojoule per mole at 298 kelvins. And we're asked to solve for this particular thing, which is the change in enthalpy for the reaction. So the first thing you have to do is for you to write out the equation that connects both internal energy and enthalpy. And it is this equation here. So change in enthalpy of the reaction minus the change in internal energy of the reaction equals change in the number of gases for products and reactants for the reaction times the gas constant times temperature. So this is what you get, right? So this is basically what you have. So you have the change in the number of gases for the reaction times R times T. So yeah, this is basically what you do. So the first thing you do now is, since we already have been given this side of the equation, which is a change in internal energy of the reaction, and we're asked to solve for what is on the right. Well, what we have to remember is we need basically math. We need to determine what is on the right side of the equation. So the first thing is for you to note what this change in n right here, what this is, right? So the change in the number of gases is just basically for you to count how many gases for the product and how many gases for the reaction. So you're going to have the final state of the reaction. So Ng of F, okay, minus the initial state of the reaction, Ng of I. So basically the number of gases for the left side of the equation, sorry, the number of gases at the final state is for you to just basically, we're going to determine that by counting it, right? So currently we have 2 molecules of carbon dioxide and then 3 molecules of water H2O. So that would be 2 plus 3 is 5. So that is the number of gases for the final state. And then that minus the number of gases for the initial state. So before the reaction occurred. And we see that ethanol is not a gas, so we can't count that. But we reacted ethanol with oxygen gas, and we had to react it with 3 molecules of oxygen gas in order for the reaction to take place. So that's going to be 5 minus 3. So change in the number of gases for the reaction is 2. So we have that information right. So yeah, that's just basically what you do. So rewriting what we have, we're just gonna rewrite this. So we just basically will solve this. Let me use a different color. We have change it in G. RT would now equal 2, okay, times the gas constant, which is 8.3145 joule per mole Kelvin, okay, times whatever this temperature is, which we're told is 298 kelvins. So of course we cancel out the Kelvin, we cancel out the Kelvin. So what you end up with is 2 times 8.3145 times 298. So what we end up having is 4955 comma, oh sorry, dot 442 joules per mole. Okay, of course, Kelvin has been cancelled out. So this is basically what you get. And this is the information that you're going to actually use and substitute in order for you to determine the change in enthalpy for the reaction. But before we go there, we have to remember that the change in internal energy of the reaction was given to us, which is negative 1373 kilojoule per mole. We're given that value in kilojoules and we have our current information in joules. So we have to go from joules here to kilojoules. So we just simply divide by 100 and we end up getting this information right here to be 4.95544 kilojoule per mole. So that is basically what is going on here. So the next thing we have to do is for us to rewrite the equation up top. So we have the change in enthalpy of the reaction equals the change right here, this change value of gas constant RT plus change in internal energy of the reaction. So yeah, that's basically it. So we substitute what we have here, the change in enthalpy of the reaction equals 4.95544 kilojoule per mole plus And then change in internal energy, we have that to be negative 1373 kilojoule per mole. So that would be negative 1373 kilojoule per mole. So of course, change in enthalpy of the reaction is just going to be 4.95544 kilojoule per mole minus 1373 kilojoule per mole. And when we input that information in the calculator, we're going to end up getting negative 1368.045 kilojoule per mole. Remember that the change in gaseous change in the number of gases for the reaction times R times T is just simply 4.9. It's a very small number in comparison to 1373. So basically this is just basically what is going on. That's why we still have a large number, because the multiplication of the change in the number of gases for the reaction times R times T gives you a small number, and then you're dealing with the internal energy, which is a large number. So we end up having a large number for the change in enthalpy for the reaction. So that's basically all that is going on here. But let's not forget that we're given this particular question in four significant figures. So we're going to stick to making sure that work is left in four significant figures. So that would end up being change in enthalpy of the reaction equals negative 1368 kilojoule per mole. So this is basically the answer to this question. So hopefully this has been made easy for you guys. If you guys have any questions, please put it in the comment section. I help students who want to succeed and be the best version of themselves when you're taking STEM related courses. So if you would like me to tutor you for chemistry, math, and other STEM related courses, make sure you email me at chuhabitutoring@gmail.com. And if you have any questions, please put it in the comment section. And if you have any questions that are personal to your struggles in school, you can always email me as well at chuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.